Okay, so 2.3 is solving quadratic equations by factoring and graphing. So we're going to solve those equations by graphing or factoring, and we're going to determine what a quadratic function equation is. Okay, so we're going to be given the roots of the function, and we are going to create the equation from that. Okay, so the first thing we're going to talk about is solving by graphing. Okay, solving by graphing. So we're solving quadratic equations by graphing or factoring and determining a quadratic function from its roots. Do you guys need any more time to fill in the objective or the title today? Okay, well let's talk about the zero of a function. So when you're solving a quadratic equation, there are many names for the solutions. The first name is a zero. Okay, the zeros can be found from the x-intercepts on the graph. But they have another name. Do you guys know another name for them? They're also called roots. Okay, so they could say find the zeros, find the x-intercepts, or find the roots. All of those are the same. Okay, we also know that if the function equals 0, so if we know that the function is equal to 0, if f of x equals 0, then that value of x is a 0 of the function. So if the equation is equal to 0, then x is a 0 of the function. Okay, so the x value that makes the equation equal to 0 is the solution. So if we are graphing to find the solutions, where are we going to look? Well, the roots are the what? Yeah, they're the what? What do we write down? They're the what? The x-intercepts. So where are we going to look? The x-axis, right? Okay, so let's just draw an example. Every quadratic equation has two solutions. Sometimes there's a double solution. So both of these would be a 0, a root, and x-intercept. Okay, so quadratic equations are x squared. That's why there's always two solutions. Sometimes there's one solution that happens twice, and that's something we'll explore a little bit later on. So in example 1, it says to find the zeros of the given function, find the zeros by using a graph and a table. So if they tell you that you have to use a graph and a table, that's what needs to be shown, okay? So they're going to ask you to solve in different ways. The first way is by graphing, and we're going to talk about multiple ways that we can do this. So for part A, we are going to find the zeros of f of x equals x squared minus 6x plus 8. And we're going to recall some of the things that we did last week, such as finding the vertex. If you're finding the vertex, we start by finding the x-coordinate. Do we remember that equation? X equals what? Good. Opposite of b over 2a. The b value is always in front of x, so this would be negative 6. But because I'm doing the opposite, it would be 6. My a value is 1. 6 divided by 2 is going to be 3. All right, and then once I know what x is, Danny, how do I find the y coordinate? What do I do? Yeah, you plug it into the original function, right? So we're going to find f of 3. So we have 3 squared minus 6 times 3 plus 8. And then I'm just going to follow my order of operations. So 9 minus 18 plus 8, which is like 17 minus 18, so negative 1. So my vertex is 3, negative 1. So I go to step 2 and I make a table. So Seth, what's the first thing I want to do when I'm making my table? What do I want to do?
You want to label your vertex.
Okay, yep. Where's that going to go?
In the middle.
Yes, so I'm going to put my vertex in the middle of the table. Here it is. I'm going to put V. And then once I know that's in the middle, I'm just going 2 up and I'm going 2 down. Alright, so to find out what the y is, I can plug in the values. We also talked about how we can use the table feature. Sometimes it's actually just quicker to plug it in. So that's what I'm going to do for this one. In part B, I'll remind you of the table feature. You guys want to race me? And who can do it faster? If you can do it on your calculator faster or mental math. 1 squared minus 6 is negative 5. Negative 5 plus 8 is 3. So if this is 3, this is 3. If I plug in 2, 2 squared minus 6 times 2 plus 8. 4 minus 12 plus 8. Going to be 12 minus 12, 0. Alright, now for these, what you want to do is you want to find where the y is 0. Because if the y is 0, what point am I finding? Or what point have I found? So the x-intercepts, will have y equal to 0. That's what I want. Okay? So if you have those, the y value is 0, we're going to label that as our z. That's a 0. This is a 0. So we got z's and v's. We got zeros and vertex. Okay, so now we're going to graph it. So I have 1 through 5. I need to go down to negative 1 and 3. So if I go by ones, that should be sufficient. Okay, so I have 1, 1, 2, 3, 2, 0, 3, negative 1, and then it's just symmetric from here. Remember, when you connect it, connect with a curve. Okay, and the main thing that we're looking for here are the x-intercepts, right? We found them in the table, but we can also see them in the graph. Okay, those are your zeros. So the zeros are 2 and 4. That would be your answer, 2 and 4. Okay? So the zeros are 2 and 4. We have our table, we have our graph. Alright, what questions do you guys have for me on part A? Okay, part B, we are going to make our table using our graphing calculator. So for part B, your equation is h of x equals x squared minus 16. Okay, so of course it's still helpful to find our vertex, so let's do that. Step 1, opposite of b over 2a. Now this does not have an x term, which means our b value is what? 0. So 0 over 2 times 1 is going to be 0. And then I need to plug it in. 0 squared minus 16 is negative 16. So our vertex is 0, negative 16. Okay, so now I'm going to go to step 2, where I do my table. So I have 0, negative 16, and if I've been doing what we have been, we would look for these values, okay? So we're going to do that part, and we're going to see something in there. All right, do you guys remember how to put that in your calculator? So go to y equals, we're doing x squared minus 16. And then do you remember where the table feature is? It's above what button? Graph. Good. So we're going to go to second graph. And then, okay, at negative 2, I'm at negative 12. At negative 1, I'm at negative 15. Okay, but this isn't very helpful yet because what am I looking for? What do we find in the graph above? What do we want to know? Yeah, we want to know the zeros. So are we looking for where x is 0 or where y is 0? Okay, where y is 0. So I'm going to have to add a few things here. So at 3, I'm at negative 7. At 4, I'm at 0. So yay. So at negative 3, I'd be at negative 7. At negative 4, I'd be 0. And I can verify that by scrolling. You can use your arrow. So you want to include the values until you find your 0, or else it's not going to cross the x-axis. Okay, so the directions say to use the graph in a table. That's why I am graphing it. If all it said is to find the zeros, I could just use my chart and I could see, oh, it's negative 4 and 4, right? Those are my zeros. Okay, but I do have to graph it. That's what the directions are asking me to do. So, what should we scale the y-axis by, you think? Based on the graph that's given. I have to go to 16. Look at all these values. 15, 12. Those are all multiples of what? 3. So I would go by 3s, right? 3, 6, 9, 12. Because I can reach 16 if I'm going by 3s, right? There's negative 15. And then with the x's, though, I can still go by 1s with the x's. All right, so let's graph. We are going to have a beautiful graph. So negative 4 is 0. Negative 3, negative 7. So 3, 6. 7 will be a little bit beneath there if I'm going by 3s. Negative 2, 12, so 3, 6, 9, 12. Negative 1, 15. And then 0, 16, so it's going to be a little bit below there. And then all of these are symmetric. So look, you're just going to go 1, 1, 2. This one is at 7, so 1, 2, 3. We have 4, 0. And we're going to connect that with a curve. And you can see, like, when you have these points here, that just helps you create a better looking graph. Just connecting those with the curve, put your arrow on there. We have a parabola. Okay, and we're just looking for those x-intercepts. So 4 and negative 4. the front. Mm-hmm.
What do we do with the zeros?
What do you mean?
Like, why do we need to have them?
Oh, so they're asking you for the zeros. The zeros are the solutions to the equation, which means if you were to plug -4 in for x and 4 in for x, it would make it a 0. So those are the solutions. Yep. And you can also find the zeros by factoring. So we are going to do more factoring today. I put a little review at the top of things that we've talked about. All right, so for the 3 steps, the first step is to look for what they have in common, right? Just like the rules of dating. First, find out what you have in common. Okay, so you're trying to take out the GCF, the greatest common factor. You always want to do that first if there is a GCF. The second thing you're going to do is look for what's special. In this case, we're looking for special patterns. Do you guys remember the 2 special patterns we talked about earlier this week? They're on your sheet. You're factoring in U. So the first one's the difference of 2 squares. Do we need to write those down again, or does that ring a bell? Remember the difference of 2 squares? If you have a squared minus b squared, it's a plus b, a minus b. Is it coming back, or should we write the pattern down again? Because they're all giving me blank stares. I'll write it down again. So it's when you have a squared minus b squared equals a plus b times a minus b. Okay, the other one that we talked about were the perfect square trinomials. And the perfect square trinomials, I told you, you could guess and check. Again, both of those patterns are on the factoring in U worksheet. And then the last thing we want to do is guess and check. And really, we always want to make sure that we are checking. And we are checking with our buddy. What's our buddy? FOIL. I always check with FOIL. Okay, and then I just made a special note. Again, this is something that we talked about. When you're factoring a trinomial, you are always multiplying to get the last number. Okay, so you multiply to get the last number. So if the last number is positive, the signs have to be the same. If the last number is negative, the signs have to be opposite. And then depending on whether the signs are opposite or the same, that is going to determine whether you are going to add or subtract to get the middle number. Okay, so you multiply to get the last number, you add or subtract to get the middle number, depending on what your signs are. And then you can always check with FOIL. That's going to make sure that you have the right factorization. Okay, so we're going to be doing lots of checking today. All right, so for 6a, notice that this is a binomial. A binomial is, so that's 2 terms. That's going to let you know you're either taking out a common factor or there might be a special pattern there. So with 6x squared and 15x, can you guys help me? What is the GCF for those two? Yeah, 3x. Okay, so the number's 3, the value's x. When you're taking out the 3x, you are going to divide. So 6x squared divided by 3x, I do 6 divided by 3 to get 2. X squared divided by x is x. Negative 15 divided by 3 is negative 5. X divided by x is 1, so you can think of it as they cancel. And then for greatest common factors, you can check using what property? Yeah, the distributive property, which is really, you're just multiplying, right? 3x times 2x is 6x squared. 3x times negative 5 is negative 15x. Okay, so after the last couple days, B is going to seem simple to you, hopefully. So with B, do you have a GCF? No. So there's no variables or numbers that go into all of them. You do have a 16, which is a perfect square, so it could possibly be a perfect square trinomial. Let's guess and start checking. And I'm going to walk you through the process. So the first thing I notice is the last value. This is a plus. So if you have a positive, you know that you have to have the same sign. If you have x squared to start, the only way you're going to get x squared is x times x. And then because the middle is negative, they are both negative. So x minus and x minus. So if I did 4 and 4, would that add up to negative 10? No. You can create a t-chart. I know some of these you are not going to need to do that with, right? So what two are going to add up to 10? 2 and 8. Okay, and when we're adding, they are negatives. And then, of course, you can check with FOIL. So when you check with FOIL, I'm going to write that just below. So x minus 2 times x minus 8. I always do that part, the x times x squared, then negative 2x minus 8x plus 16. And then I make sure that the middle terms add up to negative 10x. Okay, so yep, this is my final answer for B. We're going to skip C for now because there's two different ways you can do it, and I'm going to go over both ways with you. Okay, so we're going to come back to that. Let's go to D. I have x squared minus 9. So right away I notice this is a perfect square and this is a minus. So this could be the difference of two squares. So if I have x and x, if it's the difference of two squares, the square root of 9 is 3. So this is x plus 3 times x minus 3. And this only works with the difference. If it was plus, it wouldn't work because you need opposite values. If you check with FOIL, this is 3x minus 3x, and that makes 0x in the middle. 3 times negative 3 is negative 9. Okay, so then this is your final answer. Okay, now E, we haven't seen one like this where you have the negative in front. So I don't like working with negatives in front, so the first thing I'm going to do is factor out that negative. Okay, so if it starts with a negative, factor it out. Factor out the negative. So if you do that, it's like you're dividing everything by negative 1. So if I divide negative x squared by negative 1, I get x squared. Negative x divided by a negative is positive x. 72 divided by a negative is negative 72. And then from there, you're going to factor the trinomial. The only difference is the negative just stays on the outside. The same thing happens if you were to take a GCF out. It just stays in the front. Okay, so go ahead and factor this trinomial. Okay, so you should have started with x and x, and then you're asking yourself, what multiplies to negative 72 but adds to 1? So for negative 72, to get a negative, you know that the signs have to be opposite. So you can put plus and minus in there, or you can put minus and plus. And then if you need help thinking of the factors, you can make your chart. So 1 and 72, 2 and 36. And then I would start dividing. So like 72 divided by 3 to see what I get. And then I would divide by 4 and see that 18 goes in there. 6 and 12. And probably the one you know the best is 8 and 9.
Okay, so what is going to have, in this case, because they're opposite signs, the difference has to be -1, the difference has to be. So that's going to be 8 and 9. Which one has to be with the negative, the 8 or the 9? The larger one has to be negative, right? Because it's supposed to be, or sorry, I was looking at this one. The smaller one has to be negative in this case. So if you were to check this, 8x, -9 would not be positive x. So can't do that one. Just fine, because we're guessing and checking. All right, let's see if this works. Okay, so x times x would be x squared. -8 plus 9 is positive 1x. -8 times 9 is -72. Yep. And then if I wanted to check this using FOIL, I could do that, and then I'd have to distribute the -1. I know some people like to factor with the negative. You could distribute the negative to one of them, and that would be correct as well. All right, and then for F, the first thing I would do is see if they have anything in common. They don't. And then I noticed that this is a perfect square, so maybe it is going to be a special pattern. Let's try with guessing and checking. So to get x squared, you have x and x. It has to multiply to 25 but add to 10, so that's going to be what?
5.
Yeah, plus 5 and plus 5. So this is a perfect square trinomial. We know that because that's the same factor. So you would write that as x plus 5 squared. So if it's the same factor twice, you write it as that quantity squared, and that is your perfect square trinomial pattern. Okay, so for part C, like I said, there's two different ways that you can do this. For part C, I would recommend doing the guessing and the checking because 2 is a prime number. The method that I'm going to show you would be really helpful if you had a large number here, like if you had 16 and 12, because for 16 you could have 1 and 16, 2 and 8, 4 and 4, and that would be a lot of things to check with 12, because you have 1 and 12, 2 and 6. Okay, so I'm going to show you this method for how you could do that without the guess and the check process. And this is what was on your factoring in U worksheet, that 3B. I think some of you guys were looking at that and were trying it, which is great. So this might come a little bit easier to you if you were already trying that. So I call it the house method because I like to make a little roof. And the little roof is made from multiplying the first number and the last number. So yeah, we're starting with the roof, which is not very common when you are building a house. Okay, so 2 times -12 is what? -24. Usually I do like a whole chimney and then I put the factors in the chimney, but I didn't give myself enough room for that kind of fun today. So what we're going to do is we're going to make the T-chart, and we're going to talk about the factors of 24. So we have 1 and 24, we have 2 and 12, 3 times 8, 4 times 6. Alright, so to start this, you multiply the first and the last number, which is 24, and then we like to see all of our factors of 24. So what we're trying to do is we are trying to find the factors that are going to add up to the middle. So in this case, the middle number is 5x. And keep in mind, because this is a -24, the signs have to be what? The signs are going to be opposite. Okay, so that means these signs are going to be opposite, So you can think of it as the difference, okay? So what one of these is going to produce a difference of 5? The 3 and the 8. Now the next step is going to seem a little strange at first, but what we want to do is we want to write out the terms that are going to add to 5x, okay? So what happens is you just drop the 2x squared down, and then to determine what comes next, the 3 or the 8, you look at this. Does 2 go into 3 or does 2 go into 8? Okay, so I'm going to put the 8 next. So this is going to be plus 8x minus, what would I have to subtract to get 5x? 3x. And then we're going to drop down the negative 12. So basically what this does, it helps you create this middle part here, where if you were to take 8x and negative 3x, it would simplify to 5x. And from here, you are going to do factoring by grouping. Okay, so this part is a little bit more intensive, but you just group the first two together, and you group the second part together, and you take out the GCF. So if I take out the GCF from 2x squared and 8x, that's the only part we're going to look at right now. What can I take out of 2x squared and 8x? 2x. So I'm going to take that out. So if I take out the 2x, can you guys write what would be in there? You don't have to say it. I just want you to try it. Right? So you're dividing it, taking out the GCF. So 2x squared divided by 2x is going to give you x. And then 8x divided by 2x is going to be plus 4. All right, and then for the second set, we're going to do the same thing. See how we only have one x? I can't take out an x, but what can I take out? A 3. And actually, I'm going to take out a negative 3. I'll show you why. If I divide both by negative 3, what's going to be left in the parentheses? Okay, so in order for this to work, what has to happen is whatever is in the parentheses has to match. Okay, so when you do that, you can actually factor out the x plus 4. So what happens is, if I factor x plus 4 out, I'm going to be left with 2x, and I'm going to be left with minus 3. And this is going to be your final answer. So we're going to check this. And then we're going to talk about how this one is going to be probably easier to guess and check. So 2x times x is 2x squared, negative 3x, plus 4 times 2. See how that's my 8? 8 minus 3 is 5. Negative 3 times 4 is 12. This is your final answer. Okay, so that's another way that you can factor if you don't want to do all the guessing and checking. I feel like mentally it takes the same amount of mental work to do this as it does to guess and check. So it's honestly your preference. You do not have to do it like this. In fact, for this one, I recommend that you do not. And that's because if you have 2x squared plus 5x minus 12, you only have 2x and x. That's your only possibility. For negative 12, you only have to try 1 and 12, 2 and 6, 3 and 4, and vice versa. Okay? Now, we already know what the answer is, but you started plugging these in and saying, okay, yep, they have to be opposites. I'll try this is plus, this is minus, and then you could check with FOIL, right? Okay, no, that doesn't work, so maybe I would try the 3 and the 4. You could get there the exact same way by guessing and checking. Negative 3x. Just remember, when you have something in front, you have to multiply that to get the 5x. Okay, so you can use that method, or you can continue with the guessing and checking, whichever you like. All right, what questions do you guys have for me on the factoring section? Yeah, yep. So that all depends on the last number. So if the last number is negative, the only way you can multiply to get a negative is having 1 plus and 1 minus. So that's how I know. For this one, if it's a plus, the only way to multiply to a positive number is to have either 2 negatives or 2 positives. So this one tells you which signs you're going to use. Okay? All right, so the next step, we're actually going to do more factoring, but we're going to take it one step further because we have to find the roots and the zeros of each equation by factoring. So again, in the directions, they are telling you how you have to solve this. So if it says by factoring, you have to write out your work. Okay, so if you are going to factor with an equation, the first thing we have to do is set the equation equal to 0. Okay, so we want all the terms on one side and the other side is 0. If all the terms are already on one side of the equation, then all we have to do is say x squared minus 4x minus 12 equals 0. And then we can factor from there. So we're going to use our normal factoring rules. Can you take out the GCF? No. Okay. Is it the difference of 2 squares? Is it perfect square trinomial? No, because 12 is not a perfect square, so time to guess and check. So I have x squared, so I'm going to start with x and x. All right. Now, you know that they have to multiply to negative 12, right? So, Sam, can you tell me what the signs are going to be for this one? Not the numbers, but the signs. So, if it was a negative and a negative times a negative is a what? Yes. Yes, good. Okay, so one has to be plus, one has to be minus. It does not matter which order. Okay, so you can put the minus first if you want. Good. Okay, and then your options are 1 and 12, 2 and 6, or 3 and 4. Because those are the only things that multiply to 12. Now, you're looking for the one that when you, technically, when you subtract them, you are going to get negative 4. So which ones have a difference of 4? 2 and 6. Which one has to be negative? Good. So the 6 has to be negative. So you have 2 minus 6, which is negative 4. 2 times negative 6 is negative 12. And there's one more step, okay? And this step is based on a property called the zero product property. So we are going to use the zero product property to solve. Have you guys heard of that property before? Okay, so you actually already know it. You just don't know that that's what it was called, okay? So we're going to define it. Okay, so the zero product property we're going to put right here, and then we'll come back to that. So what does product mean? Yeah, it's what you get when you multiply, right? So the zero product property says if you multiply two numbers together, we'll just call them A and B. If you multiply A times B, and that equals 0, we know something about one of those factors. Because if you're multiplying and you get 0, what do you know? One of them has to be 0. We don't know which one. So either A has to be 0 or B has to be 0. Right? And that's something you guys all know. All your hands went up to tell me, yeah, one of those has to be 0, right? So to solve this, what we do is we set each one of these factors equal to 0. So we know that x plus 2 has to be 0, or x minus 6 has to be 0. Again, we do not know which one because both of these are going to satisfy the conditions. So if x plus 2 equals 0, we're just going to solve that for x. So I'm going to subtract 2 from both sides. So x equals negative 2. Or I can add 6 to both sides. Sorry, it's kind of hard to see. Okay, so x either equals negative 2 or x equals 6. That's your solution. X equals negative 2 or x equals 6. That is your final answer. And you are going to put the or, right? Because they both don't have to be 0, just one of them has to be 0. All right, so let's try B. So step 1, we're going to set the equation equal to 0. So I have 3x squared plus 18x equals 0. Okay, step 2, I'm going to factor. Now this is a binomial, so right away I'm looking for a pattern or a GCF. What goes into both of those? 3 and x. So let's take out 3x. And then when you're taking out the GCF, notice I always just put one parentheses because all I'm doing is dividing. Okay? So 3x squared divided by 3x is x. 18x divided by 3x is 6. Okay? And then my last step, this is a factor. 3x is a factor, so I have to set that equal to 0. So it's either 3x equals 0 or x plus 6 equals 0. So if I'm solving for x, I would divide both sides by 3, so x equals 0, or in this case I would subtract 6 from both sides, x equals negative 6. These are my two solutions. And really, you should have two solutions here. There are some special cases where both solutions are the same number, and we will see one of those. Okay, now C and D start off a little bit differently. I don't have it equals f of x. So what I have to do is I have to move everything to one side of the equation. So the first thing I'm going to do is subtract 25 from both sides. It technically doesn't matter what side it is, but I will always want my x squared to be positive, so I will always move it in the direction that will make it positive. Now right away I notice 4 and 25 are perfect squares. So this looks to me like it's going to be the difference of two squares. So I'm going to guess and check that. So the square root of 4 is 2. So 2x and 2x. Okay, and then to get a negative 25, I could have a plus 5 and a minus 5. And then I'm going to check that with FOIL. Okay, so 2x times 2x is 4x squared. This would be 10 and then negative 10x, which will make 0. And then 5 times negative 5 is 25. So, yep, this is the difference of two squares. Okay, and then for step 3, 2x plus 5 equals 0, or 2x minus 5 equals 0. And then we're just going to solve them both for x. Just be careful that when you're doing this, if you're doing the subtraction, make sure that you're keeping the signs the way they should be. So this would be x equals negative 5 over 2. For this one, I'd be adding 5 to both sides and then dividing by 2. Okay, so your final solution would be x equals negative 5 over 2 or x equals 5 over 2. And you can leave it just like that. Negative 2.5 and 2.5, that would be fine. Okay, so you go ahead and start part B. So step 1. Okay, so Dylan, what's our first step? What do we gotta get?
You gotta switch the thing, all the numbers onto one time.
Good, okay? And so be careful. I like to write my stuff out, but I know some people, they don't like writing all the subtraction and such, but I'm telling you that a big mistake people make is they just move it over and they don't change the sign. So that's why I like to write that part out. Okay, so it's the opposite when you move it over. And then those numbers are big. So the first thing I'm going to do, just like I always should, is see if they have anything in common. Okay, and what are some numbers we should try? Okay, 2. Yeah, is there a bigger one? Okay, so 6 goes into those two, it just won't go into this one. 8 goes into 48 and 32, it won't go into that. So it is going to be 2, which will help. Okay, so then this is 9x squared minus 24x plus 16. And then right away, I notice the 9 and the 16, right? Those are perfect squares. So when I'm guessing and checking for those, the 2 stays on the outside, and now I'm just looking at what's inside the parentheses. So let's see if this is a perfect square trinomial. Let's split it up into 3x and 3x, and then 16 would be 4 and 4. The signs have to be the same, but because the middle is a negative, this will be a negative. Let's check. So in the middle, I have negative 12x. On the outside, I have negative 12x. Will that be negative 24x? Yep. And then, really from here, there's a couple different ways you could do it. You could write it as like a square, and you could go from there. If you split these up, if you had 2 equals 0, can you solve that? No. So this is not a solution. For each one of these are the same, right? So you have 3x minus 4 equals 0, or 3x minus 4 equals 0. In both cases, what is your x going to equal? Yep. So if it's the same thing, this is called a double root. You don't need to worry about that. If it's the same number, you can just say x equals 4/3. It's the only thing that works. That's fine. All right. The last thing that we're going to do is not bad at all. So we're writing a quadratic function in standard form, and they're going to give you the 2 zeros. When you're writing it in standard form, that means your final equation should be f of x equals ax squared plus bx plus c. And what you're going to do is you are going to write the zeros as factors. So write the zeros in factored form. And then after you do that, you're going to FOIL and simplify. So if you write these in factored form, you can use x minus c as the form. So if you have 4, your factor would be x minus 4. Because if I were to set x minus 4 equal to 0, then x would equal 4. So if it's negative 7, what's x minus negative 7? Plus 7. And then I'm just going to FOIL, okay? So this would be x squared minus 4x plus 7x minus 28. Combine your like terms, and your final answer will be f of x equals, don't forget the f of x, and then all you have to do is FOIL, okay? All right, so your homework tonight is one where I'm going to give you points if you do it. I won't penalize you if you can't do it all. But I will tell you that the majority of your quiz is going to be 2.3, so you might want to get some practice in there, okay? And then I'll be after school tomorrow and Thursday if you guys need any help, okay, with the factoring.